Okay, so question 8 of the October 2021 paper. Let's have a look. At 7 a.m., a ship leaves the port with constant velocity. The position vector of the port is -2i and 9j. Good, so this is the position of the port and also the ship initially. So basically, if I had a 2D space, how would this look like? The port would be -2i, so you'd go -2 along the I axis. Remember, this is ij, and then 9, you go 9 along the j direction. So this is where the port is, and this is where the ship was at the start. So yeah, at 7:36 a.m., so 36 minutes later, the ship is now at 4i 6j. So 36 minutes later, the ship is 4i, so 4 along the I and then 6 along the j. So maybe like somewhere here. It's just a rough sketch. So this is where the ship is now. So the ship is moving along this direction. Maybe another 36 minutes later, it will also travel the same amount. Anyway, let's look at the question. The question says, show that the velocity of the ship is 10i minus 5j. We need to know that velocity is equal to the change in displacement over the time, which is just the final displacement. So the final displacement minus the initial displacement over how long it took. So the final displacement was, 6 minutes later, it was 4i plus 6j. So you would do 4i plus 6j minus the initial displacement, which was -2i plus 9j. So this will give me the change in displacement. And that's just equal to 4 minus -2 is 6. And then 6 minus 9 is -3. And then you want to divide it by the time. The time is 36 minutes, but you need it in hours just because everything's in hours, like kilometers per hour. So you do 36 minutes over 60 minutes an hour. And 36 over 60 gives you 0.6. So you want to divide this by 0.6. So divide both values by 0.6. This gives you the speed. So speed is equal to, the velocity vector will equal to 6 divided by 0.6. And then -3 divided by 0.6. And then, I'm not a calculator, but it should give you 10 minus 5, right? Remember, writing 10 minus 5 in this sort of format is the same thing as writing 10i minus 5j, because this is your I component and this is your j component. Okay, it says find the position vector of the ship t hours after leaving the port. So the position vector of the ship will be its initial position, which was on the port at -29, right? So this is where the ship was at the start. And I know that every t hours, right, it travels 10i minus 5j, because that's what the velocity vector represents. It represents that every hour, because the unit is kilometers per hour, every hour you go 10 kilometers across the I direction, right? You travel 10i, and then you also travel 5 kilometers in the negative j direction. So every hour the ship travels this much. So here's the ship. Every hour it's going to move around this much. Another hour later, it's going to move this much. Another hour later, it's going to move by the same amount. So this is the position of the ship t hours later. So how would you write this mathematically? You would say that the position vector of the ship t hours later would be, let's say position vector r, is equal to its initial position, which is -29. That's where it was at the start, plus the velocity vector multiplied by t. So plus t hours multiplied by the velocity vector, which was 10 minus 5. Let's say you wanted to work out the position 10 hours later. You would just do -29 plus 10 hours later, 10 minus 5. That would be -2 plus 100, and then 9 minus 50, for example. So that would be the position 10 hours later. And the position t hours later is just going to be 2 minus 9 plus t hours brackets 10 minus 5. Because remember, every hour, you're going to travel 10 along the j direction and 5 along the negative sorry, 10 along the I and 5 along the negative J. Anyway, where were we? So this would be part B. Okay, now it says at 8:48 a.m. So around 1 hour, 48 minutes later, because remember it started at 7 a.m. and now it's 8:48. So at T is 1 hour, 48 or 108 minutes, 60 plus 48 minutes. Later, this could be written as 1 point, let's do 48 over 60. So 0.8. So 1.8 hours later, 1.8 hours later, a passenger on the ship notices that a lighthouse is due east of the ship. So how I would draw this is basically, let me show you. If here's my ship at the start, okay? And I know that or I'll just draw the ship away from the diagram. Maybe it'll make more sense. The ship is moving, and then 1 hours later, maybe reaches this position. Let's call it position Z. So this is where the ship is at T is equal to 1.8 hours later. And at this position, it notices that a lighthouse is due east. So a lighthouse is anywhere. So look, this is north, this is east. There's a lighthouse somewhere east. Where east? I don't know. Okay. But maybe I can work it out. And I think that's what the question is saying. Yeah, the question is find the position of the lighthouse. So although I know the lighthouse is east of the ship 1.8 hours later, I need to work out where exactly is the lighthouse. How much east of the ship is it going to be? So first what we're going to do is let's find the position of the ship 1.8 hours later. So we're going to use the position vector, which is -29 plus T brackets 10 minus 5. We're going to plug in T is equal to 1.8. So -29 plus 1.8 hours brackets 10 minus 5. This gives me -2 plus 18, which is 16i, and then 9 plus 1.8 times -5. This is 9 minus 9, which is 0. So this is just 16i. So this is the position of the ship 1.8 hours later. So just to draw in a diagram, 1.8 hours later, the ship would be, so just 16 along the I direction will be here, 16i. So this is where the ship is now. And the lighthouse is somewhere east of the ship. So the lighthouse is anywhere along this. And let's see what other information it's given us. It's saying at 9 a.m. So basically 2 hours later, the passenger notices that the ship is now northeast. Northeast meaning like, let's say the ship is here. Northeast would be anywhere in this direction because this is east, this is north. So northeast will be at angle of 45 degrees, anywhere along this direction, like northeast of the ship. The lighthouse is now in this position. So first of all, what we're going to do is let's work out where would the ship be 2 hours later. So we're going to use the position vector again, this time for T is equal to 2 hours. So you're going to have -29 plus 2 hours multiplied by 10 minus 5. This gives you -2 plus 20 is 18. 9 minus 10 is -1. So it's just 18i minus j. So let's plot both of these in a diagram so we could understand where the lighthouse might be, the position of the lighthouse. So I'm going to draw a neater diagram. We said 1.8 hours later, the ship was at 16i. So let's label this 16i. And then at, so this was 1.8 hours later. Then 2 hours later, the ship had position vector 18i. Look, it was 18i minus j. So if I were to plot this, if this is 16, let's say this is 18, this is 18i, and then minus j. So it's like 1 along the the j direction, the negative j direction. So this is where the ship was, and this is where the ship is now. Now, we know that when the ship was at the position 16i, just play with this minus j. When the ship was at 16i, the lighthouse was somewhere east. So the lighthouse was somewhere along this blue line. And now when 2 hours later, when the ship is at 18i minus j, the lighthouse was northeast. So it's somewhere at a 45-degree angle. So it's somewhere around here, right? This is northeast. So therefore, we could conclude that the lighthouse would be the point of intersection, right? This is where the lighthouse is, because this is the point where it's northeast at 18i minus j, and it's exactly east at 16i. So now we could say that this is the, so let me use a different color. This is the point of intersection over here. Okay, so I want to know where the lighthouse is. I know the I coordinate of the lighthouse. The lighthouse has an I coordinate of, well, I don't know actually. I'm trying to work out what is the I coordinate of the lighthouse. I know the J coordinate of the lighthouse is 0. It has a J coordinate of 0 because look, the lighthouse is in J is equal to 0. Right, this is J is equal to 1, J is equal to 2, J is equal to 3. The lighthouse is along this line, so it doesn't have a J component because it crosses the x-axis basically. So I know that the J component of the lighthouse is 0, but now I need to know what is the I component. I know that this is 18i. I just want to work out what is this distance over here. And what we could do is we could extract this little, it was like a right angle triangle, where this magnitude is just 1, right? It was just like 1j. This angle is 90 degrees, and this angle is 45 degrees, and so is this angle. It's also 45 degrees, because remember, northeast would be an angle of 45 degrees. But this is an isosceles triangle because both angles are 45 degrees. So if this has a magnitude of 1, this must also have a magnitude of 1. So remember, this is minus 1j, and so this will be 1i. So this will have a magnitude of 1i. So what am I writing? 1i. So where would the lighthouse be? It would be, this is 16i, this is 18i, plus an extra i. So it would have an I value of 19i. So the position of the lighthouse is 19i. This is where the lighthouse is. It's 19i from the origin. Okay, hope that made sense. I feel like I was waffling. Find the position vector of the ship when it is due south of the lighthouse. So I want my diagram back. Okay, so when the ship is south of the lighthouse, it's going to be somewhere along this line over here, right? Because this is south of the lighthouse. So I know that when the ship is south of the lighthouse, it has a I component of 19, right? It's 19i, right? The reason it's 19i is because right below the lighthouse, which is 19i, anything along this line is 19i. This is the line 19i basically. So what I'm going to do is I'm going to write the position. So going back to the position vector of the ship. So I know that the ship has a position vector of its initial position minus 29 plus the velocity vector, which is t hours 10 minus 5. And I know t hours later that the ship is directly below the lighthouse. So the ship must have an I component of 19. But I don't know where the J component. So let's say here's the lighthouse and here's the ship. So although the ship is directly south of the lighthouse, and I know that has an I component of 19i, I don't know what its J component is. I'm not sure what the J value is. That's what I'm going to try work out. So I'm just going to put some value X for the J. And now I'm going to solve this to work this out. So let's multiply the top first. So minus 2 plus 10t, right? So minus 2i plus 10i times t is equal to 19i. That's what I'm doing. So minus 2 plus 10t is equal to 19. So therefore, we could say 10t is 21 and t is equal to 2.1 hours later. So 2.1 hours later, the ship now has a I value of 19. So the ship is now south of the lighthouse. So let's work out the J component. The J component of your ship t hours later is going to be 9 minus 5t. Okay, so let's do that. So 9 minus 5 and t is just 2.1. So this becomes 9 minus 10.5, which gives you minus 1.5. So it's going to be minus 1.5 J. So the final position of the lighthouse when it's directly south of the ship is just going to be 19i because it's right below the lighthouse, and then minus 1.5 J. And this was via calculation. I hope this makes sense. Have a lovely day.